Our research project this summer is on securing additive manufacturing and encryption techniques. To begin, within the world of additive manufacturing, there are many processes which involve sensitive design files being transferred throughout a supply chain network. The risk of unauthorized access to these design files within the supply chain is a major threat, as illegal access can lead to counterfeit and sabotage. This is especially alarming because additive manufacturing technology makes it relatively easy for someone with little to no experience to create a copy of a product with the stolen design file. In order to help prevent this unauthorized access, it becomes paramount that important intellectual property is secured through encryption methods that cannot be decrypted without the required knowledge. This will result in design creators being able to identify IP theft by looking for any traces of their encryption methods in any suspicious designs.
Our group researched and experimented with different encryption methods to safeguard STL files. One of the techniques incorporated was the inclusion of unique, visible, and hidden watermarks in the design files as shown in the figure. They were further secured with several or multiple layers of encryption. This included modifying vectors or fully encrypting the files to make it unreadable without the decryption key. Embedding features on the surface is one way to distinguish a 3D file. To test the effectiveness of the encryption methods, we attempted to decrypt them without prior knowledge.
So, our findings can be split into two major categories. The first of which is our efforts in securing and defending the 3D model itself. This usually came in the form of watermarks. So, as you can see right across the front on this 3D artifact, is just a name of a person, and this would be removed at the time of printing. However, it would be a challenge for someone who got the file illegally to take it off. But these actually serve more of as a distraction for more hidden ones. As you can see, this red circle on the top, once you zoom in into that one specific hole, you would see a line of text that says hello. Most of the time, people who are accessing this file legally would not be aware of this hidden watermark and would not remove it, which leaves it in as a preventative measure so we can notice counterfeit versions of our products, our models. These watermarks can also be placed inside of the files themselves as headers or comments, meaning that they wouldn't affect the model itself. So when you opened up the file, it would seem all fine. But once you look into file details, you might be able to see a hidden message or watermark. Then we found when it came to encrypting the files themselves, we found it very highly effective to use unique keys to secure it because it would be impossible to decrypt these files unless the the receiver had the exact same key. And in these images, you can see an example of a normal file with readable text, and then its encrypted version, which just looks like gibberish, meaning that if someone were to get their hands on this encrypted file, they could not do anything with it unless they were able to successfully decrypt it. And we also tried to use third-party softwares to password protect files, and specifically a software called Luban. What we did realize was that this third-party software was less secure than you would originally think, as they need a place to store their passwords that they are protecting your file with. And oftentimes, if it's not a cloud-based service, these passwords are stored within the physical files themselves. And through some digging, we were actually able to locate passwords that were used to secure these files through the third-party software, and thus we were able to unravel it and get the original files just by having the encrypted versions, which shows that these might not be as secure as we think.
As explained by my teammates, watermarking, embedded structures, and encrypting the files themselves were some of the ways we used for protecting our STL files, basically our design files, against any external attack or sabotage. This analysis and deployment of attack against the defended models helped us understand the sheer volume of methods that exist which can be used to compromise a digital twin. It is easy to hack into a model's digital file, and our results show that we can come up with ways, and we should come up with several ways in protecting these files, which are very important intellectual property. Thank you everyone for giving us this opportunity to work on this research problem statement. Also, special thanks to NYU for giving us this opportunity to present our findings on what our research abstract was. Signing off, Sneha, Sunaina, Javin, and Lisa. Thank you. Finally, here's a set of references which helped us come up with the possible solutions, the possible ways of tackling the different threat vectors mentioned in our abstract.